Bismillahirrahmanirrahim. I welcome you all to the online class of chemistry. Today, in this video, we will be discussing our remaining chapter, that is chapter number 6, States of Matter. Contents of this video are Introduction of Diffusion, Diffusion in gases, and in this subtopic, we will be discussing Graham's law, Diffusion in liquids, and Brownian movement. So, starting with the very basic definition of diffusion, as we have discussed this topic in biology as well. Diffusion is the movement of particles from the region of higher concentration to the lower concentration. That is, you can take an example of perfume and you can also take an example of ink droplet. The diffusion takes place in gases and in liquids both. For example, in gases, we have a perfume bottle and then we spray that perfume into the air or into the room. So, the particles that were present in the perfume bottle were in higher concentration, and then when we sprayed it into the room, it moves towards the lower concentration, that is surrounding air, that is the room. Diffusion in liquids. You can take an example of ink droplet that spreads over the water with the passage of time. Diffusion in gases. Now, we will be discussing this topic in detail with the help of this diagram. As you can see that the container that is extreme left of this picture, there are red particles and they are in higher concentration. And with the passage of time, they diffuses into the container, and you can see in the picture that is extreme right, at the extreme right, the red particles are spread all over the container. This is what happens same in the perfume bottle. That is, the particles in the perfume bottle are in higher concentration, and after spraying, they spread over the room and the particles are distributed. In this subtopic, we will be discussing Graham's law of diffusion. There was a scientist named Thomas Graham. In 1886, he studied the rate of diffusion of different gases and then formulated a law, and that law was known as Graham's law of diffusion. It states that the rate of diffusion of a gas is inversely proportional to the square root of its molecular weight. For better understanding, you should know that what does inversely proportional means. Inversely proportional means that when the one quantity is increasing, the other quantity will decrease. Same is happening here. That is, if the rate of diffusion is increasing when the molecular weight is less. Mathematically, you can see in this figure, that is the left side, before equal to we are having rate of diffusion, and after equal to at the right side we are having 1 upon under root d or 1 upon under root m. D is the density of the gas and m is the molecular weight. So the rate of diffusion is inversely proportional to the square root of density and molecular weight of the gas.